Right. Hello, everyone. Welcome to the session. It seems like we can go ahead and get started now. So thanks for taking the time to attend for today's session, COP320, Centralize Your Operations. My name's Eric Weber. I'm a Senior Specialist Solutions Architect here at AWS. Been with AWS for a little bit over 7.5 years now, working on helping customers adopt some of the centralized operations management that will be the main focus of our session today. And alongside me, I have
Hello, everyone. My name is Oren. I'm the Senior Manager for Operations Management Products. My whole reason for being, at least at work, is to build products that remove the drudgery from your day-to-day operations. All right, we can always take it down to metrics and say we want to reduce our MTTR, which we do, but at the end of the day, we want to make operations fun. We're not quite there yet, but we're definitely on the journey towards it.
Hello, I'm Badri Govindarajan. I work at MuleSoft. I'm here to say my journey on how we used SSM framework to manage our patching.
Awesome. So just to give you folks a high-level overview of what we're going to be talking about today, and you'll see we'll jump around a little bit, so we're not going to be too boxed in by the slides, at least by the slides or how they're written today. Yes, we did write the slides, but it's a presentation, and we take it a little bit more flexible. We're going to be talking about automated operations at scale. One of the biggest things that we see with customers is that they start moving into the cloud, they touch, they get a toe in, they get a couple of EC2 instances, a couple of Lambda instances, and then they blink and suddenly those numbers jump to 10,000. And the tools that they were using to manage the small amounts, either sometimes hybrid, sometimes on-prem, sometimes in the cloud, sometimes not in the cloud, don't really scale. So we're going to talk about how we do scale to those kinds of numbers and even higher. We're going to talk about how we centralize those, because one of the tenets that we have when you manage your operations is that you're going to have lots of accounts. And we all know that managing resources across accounts and regions can get a little confusing. Right? I mean, who here has ever had 15 different tabs open when they want to just find out the status of one EC2 instance? Anyone? No? No? Yeah, there we go. I have. 15's lightweight, by the way. And then also managing nodes at scale. So we all like to talk about serverless, and serverless is incredible, and we use a ton of serverless. In fact, a lot of our products themselves are built on top of serverless, but we still end up having nodes. And those nodes can be EC2 nodes, they can be hybrid nodes, they can be nodes running on just anywhere, basically. So we're going to talk about how we manage those nodes at scale. And then we're going to move to Badri, who has done an incredible job of putting together a lot of these building blocks that we're going to be talking about into a cohesive end-to-end solution for centralizing part of their operation. So we're going to be diving into that.
maybe Oren, just a quick question. So we're talking about how to centralize your operations, maybe as just a little bit of a bragging contest in some ways, I guess. How many people are currently managing, let's just say, tens of accounts just to start it? Just quick hand up. All right, let's move it up to about.
I'll tell you 1 second, I'm going to. Who here has only got one AWS account? Yes.
Hey, he's got one.
Oh, no, there is one. Okay. We will chat afterwards. I will tell you about organizations and how we get it. But that's awesome. It's awesome to see that adoption of multi-account. Sorry,
maybe more than 100 accounts? 500 accounts? Yeah, it's always somewhere right in between those 2 points. So like Oren was mentioning, logging into every single one account, trying to find your resource, that's untenable.
So a couple of customer asks that we generally see fall into kind of 3 primary categories or 3 primary asks. The first one is kind of what I touched on when I spoke about the agenda is how do I go bridge from what I used to do to what I need to do tomorrow? Right? We see, for example, like I work sometimes with systems admins or network operations folks who are transitioning from a primarily on-prem to a cloud environment, and they're maybe changing title to a DevOps engineer, and they're like, yeah, how do I used to deploy? Well, I used to like SSH or SCP onto 3 boxes, and Bob's your uncle. And suddenly it doesn't really scale when you're talking about thousands of boxes across multiple different regions and accounts, etc. So how do I build tools that will work today, but also work for the scale that I'm going to have tomorrow? And then the second one then is, okay, fine, I've built the tool, but how do I actually manage the operations then at that scale? Because it's not just about the tools, but how do I run the tools? How do I know it's safe? What happens when they fail? Not everything's perfect. Some things happen, right? And we need to fix them. And then, of course, manual. we're going from a world, we've gone from a world where it is very normal to have 1 or 2 servers only, and you have people that are literally sitting on the servers all day long, to a world of automation. And as a software dev, like, to me, that's the most exciting thing in the world, because I hate manual work. But so do a lot of people. But the problem is we still have some manual work. So how do you do that safely? How do you remove the human error when you still need humans in the equation? And so how do we get rid of that? So just before we go in, we have the numbers slide. I love this slide because to me the numbers are just mind-blowing. And I work at AWS and I see these numbers regularly and I still think that they are absolutely incredible. We have a bunch of services that run at huge scale. Now, I'm not putting these up here to say, oh my gosh, look at how awesome we are, but rather, we have encountered nearly every problem that you have encountered, and we have made nearly every mistake that our customers have made. And we have learned from them, and we're not perfect yet, but we're constantly improving. And what we are doing in our products is trying to bring a lot of the learnings that allowed us to scale to 11 quadrillion metrics, to 20 million concurrent instances that are managed within Systems Manager, to 9 billion compliance checks across config, and 850 billion auditing API requests that come through CloudTrail. What has allowed us to scale to that is a lot of these learnings that we're going to be talking about today, and a lot of those learnings are now codified into our products that we're going to be talking about. So when we talk about automating operations across all of your environments, one of the biggest problems is, what do I use? Because welcome to AWS, and we never have one way to do things. There is no one right way. I wish I could come up and just say, do you know what? I gave an AWS reInvent talk back in 2016. It had the one true way of doing things. Go watch the YouTube video, and I'll see you out on the floor. And that'd be it. That'd be the whole talk. It'd be amazing if we could do that. But the reality is that everyone's infrastructure is different. Everyone's applications are different. Everyone's services are different. The scales are different. The resiliency requirements are different. The fallback, the fall-through requirements are different. And so in order to meet your differences and your requirements, we have a lot of different services that are built to help you build to the requirements that you have versus the requirements that we have. So for configuration, you have, I'm not going to talk through all of them. This is the slide that if you're really interested, you go back later on and you look at the slide and you say, okay, config sounds really interesting. I have not looked at config for compliance. I really should, so I'm going to go into. We have a suite of configuration, observability, security, and compliance data services that all work together to make sure that you can see the metrics and the data that you need to know what is happening on your systems and where. On top of that, we have automation from Systems Manager. And automation allows you to say, in a serverless manner, let me run a bunch of code that will go and probe my systems and remediate my issues automatically for me. You can kick these off automatically as part of triggers that come from your observability, from that observability layer, the layer underneath, or you can kick those off manually. Now, again, layer on top. We like to build layers here. It's like Lego. We're building up into like a beautiful castle here. Systems Manager is split into a bunch of different segments that allow you to deal with the issues that you have at hand. So everything from change management. For example, you have an automation document, but it's a scary one. We've all heard the stories, and everyone thinks it's mythical, but I can tell you for a fact it's not. But we've all heard the stories of the person who added the extra 0 onto the end of a parameter in a command and took down 100% of a fleet instead of 10%. And again, like, it sounds mythical, right? Like there are these mythical stories that bounce around. These things actually happen. So Change Manager is there. Change management services like Change Manager are there to prevent some of these problems by saying, let me go vet some of these inputs to the automation. Event management and incident management come under a larger umbrella here. This is everything from Ops Center and Incident Manager. And then, of course, we have Node Manager, which is what I was talking about before, which I mentioned briefly, which is how we go and take those tens of thousands of EC2 instances from you and say, what you care about is your services running on the EC2 instances, but you don't care about kernel, you don't care about patching, you just care that it's done. That's the beauty of operations. Like where we want to get, the utopia of operations is, I don't care. I have a tenant. Amazon loves to build tenants for their teams. Every team sets tenants. My number one tenet for my team is be lazy. And it might sound funny, and I will be honest that some of my new hires look at me like I'm a little crazy when I give them the talk, but there is an inherent efficiency in being lazy. I want my developers to be focused on building the stuff that's actually giving value. I don't want them spending time patching instances. I have a report that runs daily. We look at it once a week, though, that tells me how many of my instances are red, i.e. unpatched. Right? We have yellow as well that's like in a patching cycle still, so they're okay. And they have red. I never want that number above 0 because I never want anyone to look at it. I don't want anyone to worry about it. I want it to be automated. I want it to be taken care of. And that's when node management comes into play. I don't want to worry about SSH behind a VPC. I don't want to worry about any of those bits. I don't want to worry about patching. I don't want to worry about SSH. I don't want to worry about how I run code on the devices. I just want someone else to take care of that for me. And then on top of that, we say, hey, you folks we currently have or using an ITSM solution, something, for example, like Jira or ServiceNow, et cetera. So we have the service management connector that helps you connect the outputs from the stack below, what we're looking at, and helps you bring it into the ticketing systems or ITSM solutions that you are already using. And then, of course, on top of that, we can start segmenting some of those items, and we can say, hey, we don't often look at all of our infrastructure. Some people do. Right? If you're a security group, you're often looking at all of your infrastructure. But for example, a lot of groups, or if you're a dev group, you're just looking at my application or my component. And so we have things like application manager and fleet manager to be able to say, hey, I'm going to segment my area into fleets or applications and look at them like that and manage them like that. And then on top of that, audit is very specific to folks who have specific auditing requirements. So this is not a general purpose service that everyone would use. I'm more than happy to chat about that more afterwards. But this is kind of your stack that builds up again. Like the point here is to say, like, we have for every layer of your operational environment that you will need to, we have services that you can put together, again, like Lego, to build the processes and the operational environment that works for you. And that helps you, your devs, your engineers, your support people, your ops people, whatever titles you use in your organizations, to help them not worry about the things that don't matter, but worry about the things that do. So, I'm going to take a break, and I'm going to have something to drink. But I'd love to make this a bit real. Right? Like, how do we talk about this? Okay, so it sounded all cool, right? But like, let's actually make this real by running through a real scenario. So, Eric, I'd love you to make this real for us.
All right, thanks, Lauren. So talking about all those different AWS services, again, building them together to have a more powerful platform underneath, kind of putting that to picture as far as a real world example, talking about microservice instability on some EC2 instances. So kind of going back to what we touched on in the beginning, if you have that single AWS account, single region, you spin up some EC2 instances, you configure your CloudWatch alarms, monitoring some metrics within the operating system, CPU, memory, disk space, application health. It's fairly rudimentary to be able to identify that resource when a problem occurs, when that CloudWatch alarm starts firing. But once we start going into the 50 AWS accounts, 100 AWS accounts, beyond that, we start provisioning our resources across all of these different locations, trying to map that correctly back to our internal CMDB. It can be very problematic once those alarms start firing, trying to identify where that issue is occurring, even just starting the issue in the first place based off of some of the observability that Oren was talking about, and then starting to actually take action and respond to it. So, centralizing all of this data, into either a central location, whether that is through a delegated admin account, which we'll be talking about, or even through that IT service management connector, it's critical to be able to pull that information back to a location where your engineers or responders, can quickly identify where they actually need to go and start troubleshooting. So let's go ahead and flip back into what are some of the tools that AWS provides that can help with that process?
You thought you were done with me. All right. So, as I said, I manage the group that builds operational management products within AWS Systems Manager. So a lot of you are probably familiar with AWS Systems Manager. You're also probably familiar with the fact that it is huge. We have a lot of stuff packed into Systems Manager. It is literally your operations toolbox, but sometimes it can be a little daunting because when you open that toolbox, everything kind of pops out. And so our goal is to make that a little easier, and we're going to break down some of the services today that we find fairly useful, especially in this context. So one of those is Ops Center. So Ops Center allows you to, well, like I said before, our goal is to reduce your mean time to resolution. And the idea here is to be able to take all of your operational issues and see them in one place across all of your accounts, within an organization, if you're not using AWS organizations, you absolutely should be using that. But we do also support a mode where you're running without AWS organizations if you happen to be in that kind of mode. The goal here is to say, hey, we've taken a signal from the observability layer. But a signal is not enough. Because when I'm woken up at 2 o'clock in the morning, when I get paged, if all I have is a ticket that says, I don't know, alarm, CloudWatch alarm for EC2 low disk space fired. That doesn't tell me much. Right? It might give me the instance name, but that doesn't tell me much. Is the instance still alive? What's the hard drive looking like? Like, what's the disk space looking like now? What's the CPU load looking like? What's the networking looking like? What's going on with that? Has anything changed? Have there been any deployments? Has anything happened? So the goal behind Ops Center, as well as its sister service, which we'll see in the demo called Incident Manager, which is Ops Center, but specifically when things are on fire. So disk space is not just low, but disk space has run out, and I was woken up at 2 o'clock in the morning. And the goal here is to enrich those signals that you're getting from your observability layer to say, I'm going to bring it all into one place. You don't need to open 15 tabs just to see what the status of your auto-scaling group is. I'm going to tell you what your auto-scaling group looks like right now, and I'm going to tell you your CloudTrail logs that are related to it in one place. You might want to go dive deeper if needed to go investigate, that's fine, but it will at least give you a starting point, and it gives it to you enriched in one location. It has deep integration into everything from CloudWatch, has single-click integration with CloudWatch alarms. Of course, I do not advocate for ClickOps, but it's a good way to get started. But we have a single-click or single-line integration via CloudFormation, and we have with CloudWatch Security Hub, EventBridge, and a bunch of others. And then, of course, we support we have bidirectional integration with the service connector, because we also recognize that, hey, you still do have your ticketing systems with their own flows and their automation and the tools that are built around that, so you probably want to have both. And so we have the service connector that allows you to say, when an ops item is created, send it over to Jira and run whatever workflows you've already got there. One of the cool things about Ops Center is it's not just about enrichment, it's also about remediation. AWS provides I believe it's over 460, and I think it's growing, so maybe after reInvent it'll be over 500, runbooks that are built-in runbooks that we provide to you that you can use to remediate your issues. Now, these are built on automation, and automation is something that you can build and extend yourself. What we see often is customers starting with automation, and they put their toe in. They're like, okay, I'll use what Amazon has provided, right? I'll reboot my EC2 instance from an ops item. I'll make my ASG enter standby, or have an instance enter standby. But where the true power of automation comes is when you say, hey, I've recognized a pattern. I have a service that's deployed onto an EC2 instance, or it's a Lambda service, and it's consuming too much memory. So this is something we see. For example, we have Lambdas that run in a high traffic region versus Lambdas that run in a low traffic region. So you have one region where the memory is high and you're paying more, and you have one region where memory is lower and you're using kind of cheaper Lambdas. And then what you have is a runbook that says, once it hits up high, yeah, I'll change it in my infrastructure as code so that it's there and locked in. But just in the meanwhile, I'll have an automation document that will bump up my Lambda memory. And I won't need a human to even worry about how to go do that. And automation documents allow you to go off and write those automations that are common for you. And the cool thing is that you can then share that across your organization. You see a theme here about how you manage your AWS accounts in organizations. But you can share those runbooks. That is an old number, that 380. It's definitely 460 plus, if not 500. But you can share those across your whole organization. So for example, what we often see is teams that share into a central repository of vetted runbooks that the company says, hey, these runbooks are really great for different scenarios, so you should use them because you know that they'll work because they've been reviewed and they've been approved, essentially. Now, what's cool about automation as well is that yes, you can write different steps that call any AWS API, but you can also use Python or PowerShell, which is obviously going to be very familiar to a lot of folks who are in the infrastructure provisioning or the operations space, so they can use the standard code that they're already used to using. They can run an automation, and it's serverless. Now, that's lying, because that's, but there are servers, but you don't have to worry about them. So from a customer's perspective, you give us the automation, you tell us, hey, run this, run it at scale, and we will just go off and run it. For those of you who are familiar with run command also uses a bunch of automation. So run command takes automation or similar documents and runs them on top of your existing infrastructure. Automation takes that to the next level and says, hey, you don't even need to run it on infrastructure. Don't provision infrastructure. We'll just run it for you, and we'll just get those done however you need it to be done.
Probably actually one more thing just to do a quick plug. A couple days ago, we also just recently launched a new feature for automation. So, Oren's talking about creating these automation runbooks, before you kind of work through, in YAML or JSON to author these automation runbooks. But now we have a visual designer, so it's more towards that low-code type model. So it's a lot easier to get started with creating these automation runbooks. And all of those runbooks that Oren mentioned, you can go into the console, see the exact code that is being performed. You can take that yourself. You can clone the runbook. So if there's ever one that is of interest, and maybe you just need another step or two, you can always just take that existing content and then reuse it yourself.
I don't know how I forgot about that. I literally spent 2 hours playing with it last night. It is a lot of fun just to play with a visual editor because there is something very magical about a visual editor for code that actually works. Like it actually just does what it says it's supposed to do. All right. So again, you've heard a bunch of theory from me. Let's go back to Eric for making this real.
Yep. So thanks, Oren, for talking about Ops Center and automation, kind of using some of those AWS tools to bring in the operational piece after working on top of the observability layer. So again, going back to the central theme of centralizing your automations, centralizing operations, again, starting with one of these member accounts, one of these child accounts within your overall AWS organization. You have that same EC2 configured with your CloudWatch alarms. But now we're adding that additional piece of putting Ops Center on top of it. So now when that alarm fires, we're going to have an ops item created over in Ops Center, which we can then flow into our delegated admin account. So again, going in the same scenario of having 50, 100 AWS accounts, have all of these ops items flow centrally so that we can view them in one single location and start taking action using automation. So when these issues are occurring, of course, the scenario will always determine what is the appropriate remediation. We talk to a lot of customers. Some of it requires manual intervention of kicking off these automation runbooks, performing the right task at the right time. It might also mean putting in place some self-healing as well. So when those actions or when those alerts are fired, let's just kick off a runbook to try and do some initial task while we're waiting for our engineers to respond to it. So pushing those executions back into those member accounts, resolving the issue. In the case of EC2, it might be as simple as just rebooting the box. Depending on the application itself, you might need to go ahead and pull some logs. These are things that AWS has out of the box ready to go within the automation capability. Another sample scenario is talking about backups. So if you have routine backups that are being performed for your compute nodes, you're creating these EBS snapshots. What happens when one of those fails? Well, we can monitor for that type of event over using EventBridge, flow through Ops Center back into that delegated admin account, and then use some automation to go ahead and resolve the issue. Final example, just being a S3 bucket. On that previous slide for that automation runbook, if you notice on the right-hand side, it was for config remediation. So config, will monitor your configuration states for compliance, and we can use automation to resolve it. So if someone happens to flip an S3 bucket from private to public, we can use Security Hub to monitor for that security event, and then kick off automation to flip that bucket back into a private state, hopefully before anyone's able to access it. And then finally, going back to what we were talking about earlier, if you are using ServiceNow or Jira, you can integrate these tools with those products. So from those locations, from their respective consoles, you can have the information that Ops Center will automatically retrieve for you, pull into those systems, as well as then you can actually take those actions. You can initiate these automation runbooks from those respective consoles as well and start resolving some of these issues. So we've been talking about what the example architectures look like, what some of these services are. Let's actually go ahead and see them in practice.
Okay, so we're going to take a look at a demo that's going to come from my laptop. It will be on screen momentarily. There we go. All right. So like I said before, Systems Manager itself has a lot of different features, and we've tried to segment them into kind of logical areas so that you can find the features that are relevant for you when you need them. We're going to start today in Ops Center, where I don't have much. It's a new account, but there's a problem with this account. I'm not quite sure what the problem is, but I can go dive in and see it. So what I'm seeing is that I have a problem with auto-scaling. And I clearly have a problem because I have two different problems with it, and one of them was created about an hour ago. That was fortuitous, considering the fact that we're here. All right. So we're going to go in, and what you're going to see here is, and let me maximize this a little bit so you can see in the back, is, again, like instead of just having a ticket that says auto-scaling EC2 instance launch failed, which is just an automatic ticket. Like I didn't create this, by the way. So this was automatically created for me. When I set up Op Center said, hey, when you're setting up Op Center, do you want me to just monitor for just standard AWS things that go wrong? And one of those things happens to be auto-scaling fails, because that is a very common failure scenario. We see people, to use a technical term, futzing with ASGs and futzing with them wrong, and ending up with this. And so one of those rules that Op Center created was, hey, if I see a CloudWatch alarm or an EventBridge notification indicating that an ASG has failed to launch, or an instance within ASG has failed to launch, I'm going to go create an ops item. Now, I'm not sure how bad that is yet, but I can go in and double check and see, like, okay, let me see what was going on here. So I can see when it was created, where it came from. So in this case, it came from EventBridge, which is awesome. I can see what resources were related to it, so I can go in and click in through here. And then once I go into the resource, so instead of having to go now, how many people know where ASGs are, by the way? Like if in the console, where would I find them? You put up your hand, I saw you. Where would I find them in the console? Pardon? Yes. Like where would I find auto-scaling groups in the console? Well done, thank you. It's under EC2. That's fine. Just checking you there. So normally I would have to go to the EC2 console. I have to find auto-scaling groups. I might type it in up here, right, and then go in. But then again, that's yet another tab. Now I do know that I have a lot of tabs open here already, but that's because of the demo. But everything right now is in this one tab. But I can actually just go in here and see. Okay, this is my auto-scaling group, and I can see actually exactly that there's probably a problem here, which is that like my desired capacity here is 1 or max 1, but my min here is 0, which is kind of a little worrying. And so I probably have some issues here, and I can go double check, and I can say, okay, what's happened with this auto-scaling group? Like, has anything gone wrong with it? And I can actually see immediately here, it's like Op Center has gone off and searched through CloudTrail and has found everything that has to do with this auto-scaling group. And you can see that some schmo, I guess, Oren, I'm not sure who that is, but someone has futzed with the auto-scaling group, and I can actually even click in. This way I will open another tab for. But I can see, that's what I'm saying, like Op Center, will allow you to drill further in without you having to go to CloudTrail and then put together a query that says, find me everything to do with the specific ASG. It's actually already showing me the exact, event that happened. It's showing me exactly what's happened, and then this is just your standard kind of CloudTrail and what was going on. So I can see that something bad has happened here. But what I can also do is, if I go back, I can go in. Actually, I can do it from here as well. I can sort of say, I'm going to run automation. Now, Op Center has said, okay, I know what's going on here. You have a problem with an ASG, so I'm going to filter through let me show you how many there are, 452 different runbooks that are available to you, and I'm going to tag 2 as associated to here because they are very commonly run in this scenario. So for example, in a scenario where you have a problem with an ASG where an instance is not being launched or isn't being launched correctly, one of the first things you might want to do is put that instance into standby so that you can go off and look at that instance and see what's going on with it. Because maybe the ASG is not configured correctly, maybe what's being deployed onto the instance is wrong. And so you want to take it out of the load balancer, you want to log into the box, you want to do your investigation and then come back out. So one of the first things you might want to do is this enter standby. So I can just run that directly here through from the console. And now I'm looking at here, and again, like this is like at 2 o'clock in the morning. I don't want to have to worry about like what is the CLI command for putting something into standby, right? So I can just run it directly. I can put in like what instances here is already, this is kind of already pre-populated for me, and I can just submit it directly. Now, the problem is, though, that in this case, I happen to be the operations team. I really should bring multiple hats. So the hat here is that I'm an operations team. And I'm looking at this, and I don't recognize this as a problem that I've encountered a lot of times. So I'm really worried, and I need someone to help me with this problem because I can't solve it. Like I've gone through my normal bits and pieces, and I need someone else. And because I'm really worried about my ASG being critical, I'm going to start an incident. So I'm going to click the button here that just says Start Incident, and I'm going to say the team that owns this is them. And I'm going to say ASG is down, and I think it's critical. So I'm going to start an incident that goes off this, and then Ops Center will transition me directly into, well, it'll tell me what's associated. And apparently I'm on call, and I just got paged for this incident. So I just got a text message with a page that says, you have been engaged into an incident, ASG is down. In the account ending in 4891, I have a link to go do it. I have an email as well, which I'm not going to show. I'm not going to bring that up. But I can also acknowledge it directly from my phone so that it stops paging me, because otherwise this will be a very noisy presentation. And then it has now woken me up. So the ops team, which hopefully was follow the sun and wasn't woken up at 2 o'clock in the morning, have now paged me, and it is 2 o'clock in the morning for me. And I am now in an incident, and I'm trying to figure out what's going on. And I've just woken up. I don't have a summary yet because no one's put one in yet, but I do have a runbook that's already run automatically as part of the incident to try to help me mitigate this issue. So I can jump to the runbooks, and this is a runbook that was written by my organization that tells me to determine customer impact. It tells me exactly what steps I need to be going and doing. It tells me I need to go update the summary so that other people can see what's going on. And then I can just click buttons to run on to the next steps automatically. So this is, think about your runbooks that are, for example, in a wiki page somewhere or in a document somewhere that are not living, they're not interactive, they can't run commands to pull data natively. You can take those and translate them into automation documents and then run them natively within your incidents so that they're pulling information relevant to your incident, and you have this click interface that is, again, like at 2 o'clock in the morning. You don't have to worry about it. You don't have to worry about where is the document, what's the link to it. Okay, I'm in it now. I'm going to read through. What step was I up to? I don't remember. I know exactly what step I'm up to. It tells me exactly where I'm up to. It tells me what state each one of them is in, and I can go off and run each one of them and progress them. I also have a timeline of the incident that tells me exactly what's going on. It tells me that, yep, I was indeed engaged. And that there is an issue here. I can go in to look at diagnoses. In this case, we don't have findings. Findings is an AIOps feature that we just launched just prior to reInvent that will go off, and there's a whole talk about this, so I'm not going to dive into it too deeply, but it will go off and look at recent deployments and recent changes in your environment that may be relevant to here. In this case, unfortunately, I made the change that caused this issue yesterday. It's a little bit old for this one to be triggering in. And then you also have the engagement, so who was engaged? Again, that would be myself.
And just to add on the engagement side,
yes.
So he demonstrated getting a text, call also works. It also has integrations with AWS chatbot, so you can get pings over in Chime, Slack, Teams. It also has integration with PagerDuty as well, so if you're using PagerDuty for your notification system, you can have Incident Manager go ahead and integrate with that.
Again, thank you. I can then dive in a little bit deeper into kind of the related items. So the related item here would be the ops item that just created that. And then, of course, we have just your standard sort of the ARNs, et cetera, like the properties of the actual incident. Now, one of the cool things that we have here is that I actually, unfortunately, cannot solve this. I need some other people here. So I can engage other people into the incident, which I'm not going to do right now because I don't want to page anyone else. But one of the things that's really important to me is making sure that everyone can see the same platform, can see exactly the same data. Because what we see when we have large-scale incidents is that everyone comes in with their metric. And we love metrics. Metrics are incredible. But the problem is it's really easy to drown in metrics. And so one of the cool things that you can do here is create a custom dashboard that gets created automatically, and it can pull directly from CloudWatch, obviously, as you would expect. Ooh. It wouldn't be a demo if it wasn't real. So normally, you can just pull directly. I don't know why the metrics aren't found. I will follow up on that afterwards. But you can put in metrics in here that will show up specific metrics, and then everyone has a view of exactly the same metrics, and everyone is talking the same language. Because otherwise what happens is you say, oh, go look at this dashboard, go look at that metric, and everyone's trying to run around, and you have competing metrics, and this way you get one set of metrics that is your true set of metrics to help you with the mitigation of that incident. Okay, So I've gone in, I've looked through my CloudTrail, and I've figured out that the biggest problem here is, of course, there are my metrics, by the way. I promise, the metrics are real. Maybe it didn't.
Missed hitting save.
Come on, can I get a
save.
clap going or something? So just very quickly, I'll show you what it actually looks like. I apparently did not hit save hard enough. But the point here is that we often have lots of metrics, but I only really need 2 metrics that are useful for here. For example, here I can see there's some problem here with my CPU spiking, going up and down. And so this way, when someone else is paged into the incident, they're already going to see a note here that says, check out don't look at my typing. CPU metrics. And so when Bob gets engaged, they're going to see a note here that says, okay, Oren's already taken a look at it. There's some problem with the CPU metrics. Let me go take a look at that. And then they'll kind of go from there. Now, don't look at the real numbers. It's a demo. This is a very low utilization metric. It should be at 100, right? That's the problem. Okay. Moving right along.
Yeah.
So what I've just shown you now here is how we go from a signal, right? You have your signal that came through, your observability signal that came through from auto-scaling group. It failed. It created off an ops item. From an ops item, I did my initial investigation. I concluded that it was worse than I thought. I then escalated it to an incident, and I ran through the incident. We did not fully resolve it. That's not the point of this talk today. There are plenty of other talks where you can dive into like incident management or resolving some of those. But what it does give you, though, is a really great segue into saying, okay, this was a node problem. So how do I manage my nodes at scale? And how do I prevent these things from happening in the future? So we're going to go back to the slides. We are going to go back to the slides. It's the magic hand wave. There we go. All right, we're going to go back to the slides. And we're going to start talking about managing nodes at scale. So one of the best ways to manage nodes at scale is to have something on the nodes that manages them at scale for you. One of the beautiful things about AWS and about running things in the cloud is that while you're running it on our infrastructure, we have zero visibility into what's happening on your instances. They are yours. We have even less visibility into instances that are running, for example, in a hybrid configuration, for example, on-prem. So how do you open up just a little hole for us to be able to manage some very small aspects of your infrastructure? We have an agent. Not really rocket science, unfortunately. The SSM agent allows you to remotely manage any node. It doesn't matter if it's an EC2 instance, doesn't matter if it's an IoT. There's a bunch of really cool demos out on the floor of folks who have like an IoT car that runs around and it's all managed like through SSM and IoT. And there's another demo of like managing like a factory with sensors that runs through SSM. And then you also have anything that's in a server or a VM. So essentially we support Linux, we support Mac OS, we support Raspberry Pi, Windows Server, etc. The agent itself is also open source, which I think is super important. You are trusting us to host your VMs and your code on our infrastructure, but now you're taking it to the next level where you're actually going to run your code on our instances. We want you to be able to go look at that code and validate what exactly is running on there. So that's why it's open source. It's on GitHub. We actually accept contributions. So if you have a really cool feature request for the agent, you are more than welcome to go and submit it there, as well as submitting code. We take code. And then the agent itself allows you to do everything from inventory collection, which we will talk about in just a moment, but also patching, which we will also talk about in just a moment, and as well as secure tunneling into those instances. So for example, this is what has allowed us to basically eliminate SSH usage across Amazon, pretty much, is by using the SSM agent and by using Session Manager and Fleet Manager to be able to get into your instances, even if they're behind a VPC, in a very secure manner. So, inventory. So inventory allows you to gather inventory, right? It's pretty self-explanatory. We like service names that are not too confusing, where we can. It allows you to gather resource metadata about everything and anything that is running on your boxes. You can even customize it so we have a bunch of standard collectible data. So things like the kernel version, OS details, network configuration, packages that are running like installed software. But you can also customize it to collect anything, right? You want to collect Is a configuration file present? Yes or no? Inventory will allow you to go do that. We can use inventory for everything from patching, such as what versions of software are running everywhere, but also things like what licenses do I have, how many of them are deployed, where are they deployed, where are they configured correctly, what legacy software am I running that's patched, but it's still legacy, as well as I want to see what's changing over time. We all know that there is that one dev team out there that even though you told everyone not to upgrade their MySQL server, they've upgraded it and they've moved to Postgres. This is how you find them. And celebrate them. The other thing that it feeds into is Patch Manager. And this is one of those areas that I was talking about before, which is you don't want anyone worrying about patching. Patching should be it's 2023, 2024 basically. Patching should be a solved problem. No one should have to worry about patching. And so the way you can do that is using Systems Manager is to automate patching at huge scale, and you can use Patch Manager to make that even easier. Patch Manager allows you to automate your patches using the rules that you care about. What kernel versions you want to go to, how quickly do you want to go to them, how aggressive are you patching, what are your reboot policies, etc. It allows you to do scanning, so you can just do a scan. I just want to know what's happening. Don't touch any of my stuff. I don't trust you yet. That's fine. You can scan, and then you will see that you do trust us and you don't want to worry about it anymore, and you'll click the button that says just set it up so that it just runs. You also want to be able to say, like, okay, like, there's a zero-day vulnerability, right? We've all been bitten by them. It can be, you know them all.
Don't bring up the bad memories.
Log4j, curl, etc. I don't know. They're still bouncing around up there. So this is a tried, true mechanism to reduce your amount of time from zero-day vulnerability to patching being installed. And then again, one of the most important things it does is consistency. You don't want every group having their own mechanism for patching. We've been there. Right? I've had dev teams who have had the weirdest scripts to do things like reinstalling OSs and rebooting machines, and they're all different at all different times, and reporting is in 7 different places. This way you have one consistent place that literally just works. Now, one of the cool things here is that what I'm talking about right now is just in an account, but as we all know, we don't all just use one account, and I would love you to tell us how we do this across a whole organization, because that's where I think the real power is.
Yes, so going into the organization focus again across all of these different accounts, across all these different regions. Earlier this year, well actually back at the beginning of the year, we launched patch policies using the quick setup capability. So patch policies allows all of those pieces that Oren was mentioning to be able to centrally define it across your organization. So put in place a well-defined scan schedule or a well-defined install operation. Have control around the types of updates that you're actually scanning to mark as missing or even approve for installation. Target those different AWS accounts as needed. You can also deploy multiple iterations of these patch policies. So like what Oren was mentioning, if there are those different application workloads that have either just different schedules that they want to patch or just different criteria, your Active Directory domain controllers or database servers, they're not going to have the same patch criteria as maybe your web app servers. So you can use patch policies to target those different accounts and get started within just a couple minutes. So it's going to take the parameters that you define, it's going to leverage CloudFormation stack sets, and then go push out those resources for you. So you don't have to put in the effort to build all of these different pieces together. As well as when we're talking about the operations side, we always have to keep debugging and troubleshooting in mind. So you can always specify an S3 bucket as well to centrally aggregate that data. So should patching go wrong, you can go ahead and dive right in. And then when we're working with Systems Manager, there are, of course, always IAM permissions involved. So this can help put in place the proper ones. So patch policies is going to help set up that operation, put in place a patch scan, put in place a patch install. And then we also have to think about how can we actually report on it. So when we're reporting on it, we're going to leverage a couple different AWS services, and it all starts with the resource data sync within Systems Manager. So this is something that you would deploy out into each of your accounts, each of your regions. And what this is going to do is going to take patch compliance data, that inventory data that Oren was mentioning, so things like what applications are installed, application versions, driver details, network details, as well as some compliance data, and ship it into a central S3 bucket. So in that S3 bucket, all of these objects are broken up by the account, by the region, all the way down to the individual managed instance as a JSON object. So since they're just JSON blobs, we can then use things like AWS glue crawlers to create a database and table for us. We don't have to build out the schema ourselves, take a look at how that JSON's formatted. We can use AWS services to automatically put some of these in place. Once we have that database and tables, we can then use Amazon Athena to go ahead and query it, ship out some information as a CSV file if people want to go ahead and check an Excel spreadsheet. Or rather than building out that query, looking at just a sample table, we can visualize that information using Amazon QuickSight. Build out some compliance dashboards, build out some application or inventory data dashboards, being able to share it out across your environment as needed. So what are the underlying pieces of this type of architecture? Again, what I was mentioning for those patch policies, it's all powered by CloudFormation stack sets. So based on the OUs that we end up targeting or the regions that we specify, Quick Setup will go ahead and tell CloudFormation to deploy those resources into those target accounts. Put in place my patch scan every single day. Maybe we have our patch install configured for dev first Saturday, QA second Saturday, prod third Saturday. We can have multiple iterations of these patch policies to comply with the differing schedules that might be needed. And then on the other side, on the reporting side, I'll actually bring up a bigger image in just a moment. But it's all focused around that resource data sync, shipping information into that S3 bucket. Again, these are JSON blobs, so if you do have third-party tools and analytics that can ingest JSON, you can get started with those right away. But the AWS services that would empower querying and visualizing would be around Glue, Athena, and QuickSight. And can we actually flip back to the laptop again? Can we flip back? Oren, I need your hand wave. No.
Sorry, the magic hand wave. We're going to do another demo. There we go. Nope, it didn't work. Uh-oh.
There we go. All right. So this is that same diagram, just bigger. This is actually from one of our public workshops. We'll be sharing a QR code in a little bit as far as how you can get to it. But I just wanted to bring this up again. We have our EC2 instances. They're performing a patch scan. They're gathering inventory data. Whenever those actions occur, the resource data sync is going to take that information right away and place it in the S3 bucket. So it's near real-time data that we're getting made available in that S3 location. So I've had conversations with customers of, I go and perform a patch. How do I know what was installed? Well, that resource data sync will ship that information for me, and I can query it right away. So let's go ahead and actually take a look. So this is the S3 bucket in this case, in this organization. All of my delegated services are in a single account. So maybe we would have this in a logging account instead. But this is that same S3 bucket. I have all of that information available to me. What are those applications installed? Billing information, compliance data, patching information, networking. Like I mentioned before, it's then further segmented by the account where those resources reside, followed by the region. And then at the bottom are those individual JSON blobs per instance. So we can take this information, again, using Glue Crawler to go ahead and build out a database and table around it. So this is a sample query that we have in that same workshop. Very basic, just going to go ahead and pull in what are my resources that are non-compliant for patching. So let me minimize this side. Oops. And if we scroll down to the bottom, I can see my list of instances that are non-compliant. I can see the very detailed information if I want. I can get more summarized information, high level. But this is going to bring together, all of that information across each of these different accounts and regions. And then finally, just again, an example patch compliance dashboard using QuickSight. So we have a workshop that's publicly available that walks you through all of these steps. It has sample CloudFormation templates as well, so we'll share the QR code in just a moment. But to put it to even a more real-world example, we'll flip back into the slides, and we'll hand it off to Badri to talk about how MuleSoft accomplished this.
Thanks, Eric. That's too much of information in like 45 minutes. And what we did is we took certain things out of it and put it into practical. So I'm from MuleSoft. What we do, we provide digital building blocks that IT departments can use to automate everything in their environment. They can integrate their data with all, and MuleSoft security is our #1 guiding principle. So all the products are have built-in security and governance in them. I specifically work in a team called Runtime Engine and Services, which hosts a platform, integration-based integration platform called Cloud Hub. Right? Yeah, Cloud Hub. With this platform, you can deploy applications in 12 regions with a single click of a button. We handle around 120 billion transactions a month. This is completely an EC2-based offering. We host our Mule runtime on these EC2s. Now, our problem statement. And in a given month, we release around 12 custom AMIs to our fleet. And we expect customers to take those updates within a specific period of time. And if they do not take those upgrades, we force upgrade them at the end of the month. As you can see in my release, this is basically our release calendar. We release an AMI on October 3rd with 0 patches. It's a new AMI, so everything is up to date. And then on October, this is a real story. This happened in October. On October 7, we had 4 patches released. And then on October 11, the famous curl patch was released, and our security teams are behind us asking us to patch quickly as possible. But the challenge in MuleSoft is we can't reboot customer boxes. They are running their workloads. They are a black box to us, but we have to patch them. How do we do that? That's where live patching comes in. So as I said, at any point in time, we run 350K instances to 400K instances. And then other challenges, all of these instances, 70% of these instances are T3 micros. They have limited memory, limited CPU. We really can't do anything on them. So we wanted some solution where we can go patch these boxes when they are taking traffic, keep the kernel up to date, and the most important thing, we should not reboot the box. We should not cause any service interruption or no latency increases, no downtime. And another thing is the Mule runtime which we ship, we want to apply those patches and make sure that we don't break it. Here is our solution on how we did it. Basically, we wanted a cloud-native solution. As Oren was saying, we did not want different solutions across different product. We wanted one single solution that anybody can adopt. Pretty much anybody who has an AWS account will be able to adopt this solution. We wanted to leverage AWS kernel live patching. Then what we did is, since our EC2 boxes are very resource intensive, and we can't afford to scan those boxes in our production environment. So what we do is, we scan, discover patches in our lower environment, we categorize those patches, test those patches, and then we update into a parameter store for different accounts. So now you have a parameter store in each account for a particular AMI. So AMI 1, these are the P1 patches. AMI 2, these are my P2 patches. Then what we do is we have a runbook and a scheduled maintenance window, which basically reads this parameter store, picks up what patch to apply on that AMI, and applies that patch one by one. And we don't apply all the patches at the same time. We start our scheduled maintenance window on a Saturday, apply the first patch, and then tag the box saying that it is patched, and then in the next 8-hour window, we apply for another patch if there is another patch that is available. This keeps on happening throughout the week. If there is a 0-day patch, if there is a 0-day patch required, we always have this other window where we use a function, Lambda functional URL, through which we can say, hey, I want to patch this resource group immediately, and it gets patched. How did we arrive here? Last year, we were basically completely a Linux 1 shop. All these 400K instances were running Linux 1. So we first migrated them to Linux 2. When we bake our AMI, we subscribe to Amazon Linux kernel live patching. With that, what it gives us is we are able to patch any kernel for up to 3 months. So if a customer doesn't take an update and he wants to basically not take any upgrade or for various reasons, we can still patch the OS without having to restart this application. Then we created a very robust testing framework for all our patches. In the lower environment, we were able to detect patches as it is. The next thing we did is we brought all our, how we segregate our EC2 boxes. We got them into tags, and then we created resource groups for using those tags for each application. Then we use System Manager, certain components in System Manager. First one is the run command, which has the logic, which uses the SSM agent in the box, logs into a box, reads the parameter store, applies the patch, and sends a feedback to an SQS queue, which says, hey, this box was patched, this box was not patched because we did not have the resource, et cetera, et cetera. Here is a screen that shows, like, this is our real production environment where we see we patched 34,000 instances last Saturday.
How long did that take you?
This takes around like 4 to 6 hours.
So 4 hours for 34,928
Yes.
instances.
Yeah, we can go faster, like basically.
We can go faster, okay.
We can go faster because a run command, there is always this option to like have how fast you want to go. Like you can parameterize this. You can say, okay, hey, I want to do 10% of my boxes. And if I see an error of 2%, just stop it. So we can play with those numbers and get it right. So we initially went slow. We went like, hey, let's spread it across 24 hours. Because a schedule window, you can do 24 hours up to max. So we tried to schedule it 24 hours. Then we shortened it, and now we are like 4 to 6 hours, and we're still playing with it. Then now, how do you scale across other teams? It's very, very easy. Now that we have this one framework where teams can plug in their own devices. So what we do is we ask teams to do is, hey, bring in your own resource group. The run command is there, and then use a schedule maintenance window to schedule your resource group to be patched during that time. This is what I call like bring your own device, get it patched. Where we are today, like luckily, like we released this in October. And the first week we released it, we found out our security teams were like, hey, there is a curl patch coming up. We need to patch immediately. So we used this to immediately patch all our boxes. Then now we patch our EC2 boxes twice a week. Or we can even increase it to go more, but we are currently doing it like twice a week. Then our security teams are very happy now. We maintain our patching SLA. Throughout this process, we learned a lot. We took a lot of trial and error to get this going. First thing, we use resource group. Resource group is an eventual consistent database. So there are times where we had terminated instance on our resource group, and our maintenance window would pick up that and then hang. That was one problem. Then we ran into concurrency issues, or like we ran into concurrency limits with automation document. Then we moved to run commands, which helped us scale much faster. Another big problem is like we scan our patches at the lower environment. So there is always a difference, like you would see something that is requiring a patch in a different region, but it is not available in a different region. So we are still working through these issues.
All right, awesome. Thank you, Badri. So again, patching at such a large scale, 400,000 plus EC2 instances twice a week. That's incredible. So that is going to wrap up. Can you go to the next one? So that's going to wrap up our session today. Like I mentioned before, if you're looking to get started with Systems Manager, there's 2 different QR codes here. The one on the left-hand side is going to be for Skill Builder. Get a 100-ish level introduction to Systems Manager as a broad scope. And then, once you're ready to actually get some hands-on experience, the right-hand QR code is for that 200, 300, 400 level type of topics where you can actually try things out for various different use cases, including all of that patching portion that I showed within the console, going through Athena, going through QuickSight, and creating dashboards around it. And then can you go to the next one? Of course, if you have more questions, we'll actually be around after the session today. But we do have a booth over in the expo hall for the Cloud Ops kiosk. Please visit us there. We have lots of different staff experts that are there. So if you do have any questions around observability or operations, happy to answer your questions. And we also have some prizes, of course. So thank you again, everyone, for taking the time. I know it was a late afternoon session, but I hope you learned a lot. I know it was a lot of content that we went through. Obligatory, please fill out the session survey. We're metrics driven. We're always looking to improve. So let us know. And again, we'll be around afterwards. If there's any other additional questions. Thank you.
Thank you.
Thank you.